when we're talking about uh, normal distribution, we're talking about data. And if you take enough data points, there should be what we call is the normal curve. So you've got this would be your average, okay? And then on each side, your standard deviation is the typical value away from the mean. So here is one standard deviation, and here is one standard deviation. But we talk about this standard deviation as negative because it's to the left, or we're subtracting a standard deviation from the mean. So we could have one standard deviation, and then we could have another standard deviation. So this would be two standard deviations. And same thing over here, we would have negative two standard deviations. And then we would even have what's called the third standard deviation. This is the same thing over here. Now, we also have, it's a rule, and it looks like y'all get a little bit more specific with it right here. So this rule right here says that within one standard deviation, which means one standard deviation to the left and to the right, there's going to be 0.683 of the population. So about 68%. Now within two standard deviations, there's around 0.955. Typically what we say is 68% and 95%, but y'all are getting a little bit more specific right here with it. Okay. And then actually between the third standard deviation, there's going to be 99.7%. So there could still be some values to the left and to the right of the third standard deviation, but there's not going to be a lot. Okay. There's only going to be about 0.3%. So that's how we're coming up with these values here. Or that's where those values come from. Now, to solve this type of probability here, it wants you to take from the mean and two standard deviations to the left, and then it wants the mean and one standard deviation to the right. It wants to know what is the probability that falls between these data points. So basically we're going two standard deviations to the left and one standard deviation to the right of our mean. So now then, there's a couple of different ways that you can actually do that. Some people, you can have what's called there's a table that you can look at to find that. But here, what they're doing is, since we've already said that from here for standard deviation of two standard deviations, this would equal about 9.55, right? But we are only wanting to figure out, for this first part, we're going to solve between here and here. So we can half that. That's where they get this 1/2. So we have 1/2 of 0.955. But now we still have to consider from here to here. Well, to do that, we know that from one standard deviation to the right and to the left is 68.3. So we can add half of that, because we're only going half of it. We're not going from the negative standard deviation to here. We're just going from X to that, because that gives us the total. We would now have this portion and this portion covered by those 2 points. Okay, so we're going to once again have to half that. And that's going to give us our answer, whatever that was. So that is 0.4775, and then plus 0.3415, and we add that together, we get 0.819. So if we talk about that in terms of the probability of finding the values, or any value picked, falls in this portion. So between a negative 2 standard deviations and 1 standard deviation, the probability of a value being found in that area is 0.819, or we could call that, we would round that to probably 82% of any value of our data set, because you've got a bunch of data points. But we know that in between a negative 2 standard deviations and 1 standard deviation, the odds of having any data value in there is about 82%.